Today we'll be making a video or demonstrating our capstone project, breast cancer tumor detection using machine learning. Our objective in this project to build a breast cancer detection model based on machine learning, which helps detect tumors obscured by dense breast tissue. The model should be able to decide whether the input image is normal, abnormal, and further detect and classify tumor as benign or malignant. We'll be using CNNs on MIAS and CBIS DDSM datasets. So what is breast cancer and why does it need to be detected early? It is the malignant tumor that activates in the cells of the breast. A tumor has the potential to spread to other parts of the body too. With this potential rise in the number of cases in India, the distress is alarming. Mammography is a reliable and trustworthy tool for early detection of breast cancer. Early detection and diagnosis can save lives of cancer patients, and it is essential for finding best treatment and reducing mortality. So the need for computer-based models. Manual classification is challenging and time-consuming, and also highly susceptible to inter-observer variability and human errors. Such manual attempts are time-consuming, inefficient, and inefficient in many cases. Hence, there is a need to introduce computer-based models.
Working on MIAS. Now, the dataset we used was MIAS, which is Mammographic Image Analysis Society, which contains 322 digital images, among which 67 lesions are benign and 53 lesions are malignant. The work done on the dataset is data pre-processing and image processing, augmentation, training and testing the model, and finding the accuracy. The following steps were thought to be done for the pre-processings, which were removal of pectoral removal, muscles, removal of label and artifacts, suppressing, filtering, normalization, and noise removal.
Sometimes an image contains certain artifacts or unwanted regions in it that may be undesirable, and they might reduce the accuracy of our system. So recognizing such regions are important to get rid of them. Next. Noise removal. The objective of removing noise from a mammogram image is to get the best estimation from the noisy data for further processing. These are the following steps that were involved in removal of labels and artifacts. Crop edges, binarization, contour creation, and selecting maximum area contour for final mask. Gaussian and median blurring to smooth out edges for final mask. Applying mask to original image. Next, crop edges. So while creating mask, we noticed that in some images, the contours were possibly joined by pixels that were not visible to the naked eye. So to remove these joins and separate various parts of the image, we cropped out a few pixels worth of borders from all the edges. Binarization is basically done for converting any image into black and white image using thresholding. We need this basic black and white image for creating masks.
Now, the third step was contour creation and selecting maximum area contour for final mask. In this, the black and white image, we need to calculate the area of each separate white part, and in the image, and from these we shall select the largest lesion. We create these contours using contour selection. Now, the next step was Gaussian and median blurring. Gaussian and median blurring is used to smoothen the edges of the contours of the breast. Now, the last step was applying mask to original image. Bitwise and of the original image and mask is done to obtain a clear label-free image. Now, all the steps are combined, and the following results were observed after each step.
Data augmentation is used to increase the amount of data by adding slightly modified copies of already existing data. It acts as a regularizer and helps reduce overfitting when training a machine learning model. What we have done here for CNN is we want bigger data size, and MIA's dataset provides us with 322 images. So we needed more data and took every image and rotated it 1 degree till 360 to make more copies of the initial data. Next. Model. The prediction accuracy of machine learning model is reliant on the amount and diversity of data available during training, and also the number of layers in the model. CNN is composed of multiple layers of artificial neuron. We use some dropout to prevent overfitting and have used activation functions such as rainbow and softmax. This model, after running, provided us with an accuracy of 55%, which is undesirable.
After successfully augmenting the data and trying various models, we finalized the following CNN-based model as it was the most accurate one. As we can see, we have used convolution layer, which is conv2D, and pooling layer, maxpool 2D, for its implementation. Now, convolution layer is in a CNN summarizes the presence of features in an input image, and pooling is required to downsample the detection of features in feature maps. Next. After successfully building the model, we started with the evaluation of it, as it is very necessary for checking the performance of the model. For output and evaluation of the model, we use the following parameters: accuracy, precision, recall, F1 score, ROC, area under the curve, and Cohen-Kappa score. Following were the results obtained. As we can see, the accuracy obtained was close to 99%, and other parameters are also around the 98% mark. So we can conclude that the model was successfully built and implemented and serves its purpose. Thank you.